Hi, welcome to Adam and Sarah's final project. So we created a galvanic cell, um, and so for this mini lesson, we're just going to explain what a galvanic cell is and how it works, and then we will show you our cell. So a galvanic cell is also called a voltaic cell. These words are interchangeable, and it utilizes spontaneous redox reactions to create a battery. So galvanic cell essentially is a battery. And redox stands for oxidation reduction. And it's when you have one reaction that is going through oxidation and one reaction that is going through reduction that you then have a redox reaction. And so what does oxidation mean? It means when a reaction is losing electrons. And reduction is when you're gaining electrons. So a way to remember this is Leo says Gur, losing electrons oxidation, gaining electrons reduction. All right, great. So for an example of a oxidation reaction, we can look at zinc solid going to zinc 2 plus and 2 electrons. Here we can see that zinc originally had an oxidation state of 0, and then it had an oxidation state of 2 plus. If something is becoming more positive, that means that it is losing electrons. And if you lose electrons, Leo says Gur, that must be oxidation. And then an example for reduction, let's say you have copper 2 plus 2 electrons gets you some solid copper right there. Well, you're going from a 2 plus charge to a charge of 0, and to become less positive, you have to gain electrons. So that is what a reduction reaction looks like. So assuming that both the zinc reaction and the copper reaction are spontaneous, you would then get a spontaneous redox reaction that could be used in a galvanic cell. Okay, so now that we reviewed redox, this is how it pertains to a cell. So on one side here, you're going to have a half cell. How do I write? Oh, one half cell, and then this is another half cell. And these are where your two different reactions proceed. And so if you have an oxidation reaction that is losing electrons, and then a redox reaction that is gaining electrons, that means that if one thing is losing electrons and another thing is trying to gain some electrons, the electrons can flow from the oxidation to the reduction right here. Cool, so that's where this place of oxidation is called the anode, and the place of reduction is called the cathode. And so together that makes N-ox, red cat. That's like, it's kind of like a Leo says Gur, but for the cell. So if we have zinc solid becoming zinc 2 plus and 2 electrons, that is the oxidation, meaning this must be the anode on this side here. And then this is copper 2 plus becoming copper solid, and then, sorry, I forgot 2 electrons here. So this is reduction. So this must be the cathode. So we know that electrons are going to flow from anode or oxidation to cathode or reduction. So we know that electrons are flowing this direction in the cell. And as they're flowing, you're creating a charge, and this is the charge in volts. yeah, so that's the basics. And then you might notice this tube right here, that is the salt bridge. And the purpose of this is because if the zinc is losing all of these electrons, you're going to end up with a positive charge over here. And if copper is gaining these electrons, you're going to end up with a negative charge over here. And the cell cannot run if you end up with this unequal charge. So the salt bridge exists because it pours negative ions into the side that's becoming positive, and it puts positive ions into the side that's becoming negative. Yeah, that's pretty much it. And then these solid metals right here, here, and here are called the electrodes. And then this is just the solution they're in right here. And then this is just like some inert wire. We used alligator clips in ours. And that is how that works.
So right here, this funny blue liquid is copper nitrate. And over here in the anode is iron nitrate. So these are the aqueous solutions that allow the reaction to progress. And what connects all of this, right? What allows the iron and the copper solutions to interact is this thing, the salt bridge, which is essentially a glass tube containing KCl, in our case, that allows the reaction to progress. And up here, we have the voltometer, which measures the energy produced by our reaction and produced by our cell itself. So it would give us a number like 1.2 volts, for example. And in our actual demo, you'll see that we used alligator clips to connect the electrodes to the voltometer, which allowed us to get the reading. All right, so let's go back to these solutions, the anode and the cathode, and talk about what that all means. So there are, at each half cell, there is a half reaction that plays out and goes towards the full reaction that's happening in the cell. So at the anode, it's an oxidation reaction. So we start with a neutral iron atom, solid iron. And as the reaction progresses, we get Fe2 plus 2E minus. And then copper, cathode, NOx red cat, it's reducing. So we have copper 2 plus 2E minus. And because the charge is reducing, we go to a zero charge. Sorry, add the aqueous right there.
Hello, technical difficulties. So we're here at the whiteboard to continue talking about E-cell. E-cell being the voltage produced by the reaction in our cell. And if you remember, there are the two half cells, and at each one there is a different half reaction occurring that in total add up to our total reaction that gives us our E-cell. So if you remember, at the anode there was the iron electrode and the iron solution, and the reaction that occurs over there is iron actually oxidizing to produce iron ion and 2 electrons. But in your book, the way you'll find this written out is going to be going this way, because in your appendix, you will see a bunch of half reactions that are sorted out by their reduction potential. So if you look for iron 2 plus, you will find this written right there, and you will see its reduction potential. Its standard reduction potential is negative 0.337. And so what's actually happening though in our reaction is that the iron is rusting and that it's oxidizing into the iron ion and more electrons. So what's actually happening is the iron solid producing the ion and the electrons. So what do? We take the reduction potential and we just flip it. That gives us the oxidation potential, and so we take the inverse. So we have a positive 0.337, and that is the new potential with the flipped reaction. Copper is much simpler. Because copper is a reduction reaction, we can just take this half reaction from our appendix, get the standard reduction potential, which is positive 0.440, and all we have to do is add those up. So we have 0.337 plus 0.440 gives us 0.777 volts, which is the E cell for our galvanic cell, which makes sense because galvanic cells have to have a positive E cell.
She take my money when I'm in need. Yeah, she's a trifling friend in me.
Now I ain't saying she a gold digger, but she ain't messing with no broke. Now I ain't saying she a gold digger, but she ain't messing with no broke. Get down, girl, gon' ahead, get down. Get down, girl, gon' ahead, get down. Get down, girl, gon' ahead, get down. Get down, girl, go ahead.
Find some peace tonight in the arms of the angel. Fly away.
Lena, Trina, Gina for Lopez, 4 kids, and I gotta take all they bad. Get your kids, but then they got their friends. I pulled up in the Benz, they all got a bin. We all went to den, and then I had to pay. If you fucking with this girl, then you better be paid. You know why? Take too much to touch her. From what I heard, she got a baby by Buster. My best friend said she used to fuck with Usher. I don't care what none of y'all say, I still love her. Now I ain't saying she a gold digger, but she ain't messing with no broke. Now I ain't saying she a gold digger, but she ain't messing with no broke. Get down, girl, gon' ahead, get down. Get down, girl, gon' ahead, get down. Get down, girl, gon' ahead, get down. Get down, girl, gon' ahead. 18 years, she got one of your kids, got you for 18 years. I know somebody paying child support for one of his kids. His baby mama car crib is bigger than his. You will see him on TV any given Sunday. Win the Super Bowl and drive off in a Hyundai. She was supposed to buy your shorty Tyco with your money. She went to the doctor, got lipo with your money. She walk around looking like Michael with your money. Shoulda got that insured Geico for your money. If you ain't no punk, holla, we want prenup. We want prenup, yeah. It's something that you need to have. And when she leave, she gon' leave with half. 18 years, and on her 18th birthday, found out it wasn't his. Now I ain't saying she a gold digger, but she ain't messing with no broke. Now